Jai Hind class. Today we are going to discuss chapter 2, Is Matter Around Us Pure? In this chapter, first of all, we will read about classification of matter. Anything which occupies space and has mass is called as matter. The basis of classification are physical state. Matter is classified as solid, liquid and gas. On the basis of chemical composition, we can classify matter as pure substance and mixtures. Pure substances are of two types, elements and compounds. Similarly, we have mixtures of two types, that is homogeneous and heterogeneous. Now, first of all, before we continue with this classification, we should know the basic terms which are related to the matter classification. First is atom, it is the smallest unit of matter. Then we have molecule, which is a group of atoms bonded together. Then we have element, which is actually the purest form of matter, and it consists of atoms of single type only. Then we have molecules of matter of two types, like molecules of element and molecules of compound. Molecules of element will contain alike atoms like oxygen, nitrogen, etc. Similarly, molecules of compound will contain atoms of more than one type like water, salt, etc. If we have to define pure substance is a substance which consists of single type of substance, that is one type of particles only. Example, oxygen, water. Oxygen is an element which is a pure substance. Similarly, water is a compound which contain particles of more than one type, but all particles are alike, that is they are water particles. That is why we consider compound water, and that is a pure substance. Similarly, when we talk of mixtures, mixture is a substance which consists of two or more pure substances which can be separated by simple physical methods. Mixtures will include seawater, mineral, soil, air, etc. Then this is the differentiating table between element and compound, how we can differentiate pure substances also, that is in terms of elements and compounds. Like we talked of element having similar particles, similar atoms. We talk of compounds, then they will have atoms of more than one type, hence they can have two or more elements which are mixed together in definite proportion by mass. Then element have their own fixed physical and chemical properties, but physical and chemical properties of compound are totally different from its constituent elements. Atom is the smallest particle of an element taking part in a chemical reaction. Compound cannot be separated into its constituents by simple physical methods. Now this is the differentiation between compound and mixture. We can say this is the differentiation between pure substance and impure substance, because compounds come in the category of pure substance and mixtures come in the category of impure substance. So pure substance consists of single type of substances or particles, and mixture consists of two or more pure substances or particles of two or more different types. Pure substance cannot be separated by constituent elements by physical methods, but mixtures can be separated into its components by physical methods. Pure substance has its own definite properties which differ from constituent elements, like hydrogen and oxygen are combustible, but water is not combustible. Mixture shows properties of its own component, of its own. It has properties. Example, mixture of sulfur and iron, both retain their properties even after they are mixed. So the properties of mixture resemble the properties of its components. Then this is the differentiation between compounds and mixtures further. Then we have types of mixtures, that is of two types, homogeneous and heterogeneous mixtures. Homogeneous mixtures are those which have properties all alike in all the parts of the mixture, means its properties are throughout same. When we talk of homogeneous mixture, we will take into account mixtures like sugar solution, salt solution, etc. Once the sugar or salt is soluble, properties of mixture throughout the solution are same. Then here are some examples of homogeneous mixture where you see uniform distribution of the solute throughout the solution. Then we have heterogeneous mixtures which have properties, different properties in different parts. So we can say there are boundaries between the constituent. For example, suppose we have sand in water. Then you see that once you allow the solution to stand, sand is at the bottom and water is at the top, and almost the suspended particles which are very small could be seen in the solution. So here the components have distinct boundaries. So we can say heterogeneous solutions are those which have different properties in different parts. Then when we talk of solutions further, we come across the term true solutions. These are the solutions which have actually homogeneous solutions which have two or more substances, means one solute and one solution. Then what we find, the important properties of these solutions are that they are homogeneous in nature. Solute particles are completely soluble in the solution, so they are not visible to naked eye. Then solute particles we cannot separate by filtration as they are completely soluble. Then solution is stable because the solute is uniformly distributed throughout the solution, and there are no sedimentation seen. There is no sedimentation seen because the solute particles cannot settle down at the bottom. Similarly, they cannot show Tyndall effect, that is the scattering of beam of light if passed through the solution, as the particles are small enough that they cannot actually scatter light. Then these are some of the examples of true solution. We talk about aerated rings, we talk about tincture of iodine, then alloys. They all are the examples of true solution. Then comes colloidal solutions, which are actually heterogeneous in nature, and the particles are bigger than true solution particles. And we have in colloids a dispersed phase and dispersing medium. When we talk of colloids, dispersed phase is actually same role playing as the solute in the solution, and dispersing medium is playing the same role as solvent in true solution. Then examples of colloids we can see starch in water, mixture of egg albumin in water, milk, etc. Now the important properties of true solution: heterogeneous nature, particles of dispersed phase can't be seen by naked eye, then particles of dispersed phase cannot be separated by filtration. So these are some of the important properties of colloids which are actually different from true solution. Then these are some of the examples of colloid, different categories of colloid with the dispersed phase and dispersing medium, followed by some examples. Then we have types of colloid like emulsions, foams, aerosols, solid gel, etc., solid sol, etc. These are the colloid where there is difference in dispersed phase and dispersed medium, and according to this dispersed phase and dispersion medium separation, they are categorized into different categories. Then comes suspension, which is actually heterogeneous mixture of two or more substances. Suspension has an insoluble solute mixed in a solvent, so we can see the solute in the solution itself. Now the properties: heterogeneous nature, particles are big enough that they can be seen by naked eye. If we compare solution, colloid and suspension, we can say the particles of suspension will be biggest and particles of solution, true solution, will be smallest. And the particles of colloid are midway between true solution and suspension. Then particles can be seen by naked eye, then the particles can be separated by filtration, and you can see sedimentation of the solute particles happening here, and they are able to show Tyndall effect, that is scattering of light when beam of light is passed through this suspension. Now when we talk of Tyndall effect, it is a scattering of light by particles of colloid or suspension, and this allows the path of light becoming visible through the suspension or colloid. So the examples of Tyndall effect which you see in your daily lives is when the beam of light is entering through in a dark room through a window pane. You see dust particles scattered in air. And the other example is when you see there is a canopy of trees in dense forest and a beam of light enters through that canopy of trees, you see the dust particles scattered in light. So these are the examples of Tyndall effect. Thank you.